Okay, so we are going to start off. This is a review from some of the function notation stuff. I'm also going to add in a little bit of stuff you're going to be covering in college algebra next week, just kind of as a head start for next week. Okay, so I gave you 3 graphs. I didn't tell you anything about these graphs. I just gave you the graph. I didn't tell you the equation. I didn't tell you what kind of graph it was or anything like that. So let's find a few things here. Let's start off and find f of 2. So just a reminder, finding f of 2 means we know that x equals 2. Find what y equals. And you can do that on your graph. If you go over on your graph to x equals 2, and you go up to the line, you have an ordered pair right there. What's the y value of that ordered pair? 5. So f of 2 is 5. Okay, on your own, find f of 0. So you go to your graph, at the x value of 0, you have a y value of 2. So f of 0 is 2. That specific point has a name. What's the name of that point? Yeah, it's where it crosses the y-axis. So that's actually also the y-intercept. We kind of talked about that last time. Okay, so the next thing we're going to do here, let's go and talk about the slope of that line. We talked about slope a little bit last time. Slope, remember, is rise over run. We talked about how to find slope from an equation. Today we're actually going to talk about how to find slope from 2 ordered pairs. But in this case, I can find slope here because I can pick 2 points and count how much I have to go up and how much I have to go over to get to the next point. So if I start at this bottom point at 0, 2, how much do you need to go up to get to the next point? 1, 2, 3. So my slope would be 3 on top. It's positive 3 because I had to go up. And then I have to go over to the right, 1, 2. So it would be the number 2 on bottom. Going to the right is positive and going to the left is negative. Okay, you could also go the opposite direction. If you started on the top and went to the bottom, the other way to do it is I went down 1, 2, 3. So that would be like negative 3 on top. I went to the left 1, 2. So that would be a negative 2 on bottom. And what's a negative divided by a negative? A positive. So it would still be 3 over 2. Okay, so it actually doesn't matter which way you go. You'll get the same answer either way. Okay, let's talk about domain. Does anybody know what domain means? Good job. Yeah, domain is the x values. So for this line, if I'm trying to write the domain, I'm trying to write or trying to tell what x values this line has. Okay, this line, I put 3 specific dots on here so you can see specific points on there. But how many dots are actually on this line? Infinity, technically. Like technically it's a bunch of little tiny dots all put together that make it look like one big line. Okay, because it's like I could write an ordered pair for this dot right here. It wouldn't be fun to do it, but the ordered pair would be like 1.4 and then like 3.9 or something like that. Okay, so you could have that ordered pair. It's not pretty, but you could technically have it. Okay, so domain is asking what x values could I write an ordered pair for, essentially, on this line. Okay, is there any place where this graph starts or stops? How do you know that? Because it gave me arrows at the end. It keeps on going on forever and ever and ever. So the domain here would be, where does it start at on the left? Negative infinity. And where does it end at on the right? Positive infinity. So your domain is from negative infinity to positive infinity. It's kind of like asking basically how wide is the graph? Well, it goes on forever, so it doesn't actually have a width here. It's just infinity. Okay, range is the y values. It's the same thing, but I'm looking at the y values this time. So the idea for range is like the height of the graph. Where does it start out on the bottom? Where does it end out on the top? For this graph, it goes on forever. So what would be the lowest point on this graph? Negative infinity. And what would be the highest point? Positive infinity. Does that make sense? Okay, you'll start talking about that in college algebra this next week. Look at the next graph. This is similar to the one we did last time. I want you to find f of 4 here. If you go over to the x value of 4, it's this dot right here on your graph. What is that ordered pair? It would be, I think it's -2, right? It would be -2. Hey, Nikosi, I have that you're here. If you need to talk to me, you can talk to me on the chat. Okay. So yeah, f of 4 would be -2. And remember the other one we did was all values such that f of x equals 1. Okay, so remember that one is, I'm looking for x, my y value is 1 this time. So go on your graph and find the points where your y value is 1. That'd be this point here and this point here. What are the x values for those 2 points? Yeah, -1 and +7. So x is -1 and +7. Okay, what are your x-intercepts for this graph? Z 6, 0, right? So over 6 up 0 is one of them. What's your other x-intercept here? Right here at 0, 0. What's your y-intercept here? 0, 0 is where it crosses the y-axis. Okay, sometimes your x-intercept and your y-intercept can be the exact same. And let's think about the situation where it can be the same. What does it have to be for it to be an x-intercept? What do we know about every single x-intercept? It has to cross the x-axis. Looking at the ordered pairs, what do we know about all x-intercepts? The y is 0, right? What do we know about all y-intercepts? The x is 0. So what situation could it be an x and y-intercept? When it's the origin, when it's 0, 0, because then you have a 0 on both of them, right? Okay, and let's do domain and range. The domain for this one, how wide is this graph? Where does it start out on the left? Where does it end out on the right? It's -infinity to +infinity because it keeps on going forever, left and right. Okay, so domain is -infinity to +infinity. Your range is how tall your graph is. Where does it start out on the bottom, end out on the top? Does it go forever both ways? No, it only goes forever up. It has a starting point at the bottom. What's the starting point at the bottom? -3. And then it goes up forever. So it would be -3 to infinity. Infinity has the parentheses, the -3. It's going to be a bracket because that's a filled in circle. Okay. Questions about that? Okay, let's look at the third graph. Let's write the x-intercepts for the third graph. Take a second and you write them on your own. Okay, so what are the x-intercepts here? 1, 0, 8, 0, and -6, 0. I have 3 different x-intercepts here. Okay, let's do the domain here. What's the domain? How wide is it? Where does it start out on the left, end out on the right? It's -infinity to positive infinity, right? Most functions have a domain of -infinity to positive infinity. There are some that don't have that. And there's also, like, I could take a chunk of this graph. I could have like stopped at this dot. If I didn't put these arrows at the end, that would have actual domain with numbers, right? Because it doesn't go on forever. It'd start over here on this number and it end over here on this number. Okay. But if they have arrows on the ends, for the most part, not every situation ever, but for the most part, they are -infinity to positive infinity. The range here. Okay, so if you'll look on this top hump, it goes all the way up to +3. This bottom hump goes all the way down to -3, and then it turns and it starts going the other way. But if you look on the outside of that, like it goes down below -3 with this arrow, and it goes up above +3 with this arrow. So what would the range be? Yeah, -infinity to positive infinity. Questions about that? Okay, so I hope that kind of helped clear up a little bit of interval notation with graphs. That's part of the reason why we learned interval notation. You'll start seeing that in college algebra next week. Okay, start on Monday, Tuesday, Wednesday. Okay, so last time we ended on x and y intercepts. Let's review that real fast. Let's do one problem of that, and then we will move on to the next couple things. Okay, so x and y intercepts. This is section 3.3, review. What is an x-intercept? We just talked about that. Or how do you find an x-intercept? It's where it crosses the x-axis. How do I find it, excuse me, from an equation? Yeah, plug in 0 for y, solve for x, right? Plug in y equals 0. For a y-intercept, how do I find a y-intercept? Plug in x equals 0. Okay, so if we had the problem 3x plus 7y equals 21. And we want to find the x and y intercepts and then graph it. So this is where you have to work out this problem 2 times. To find the x-intercept, I'm going to plug in 0 for y. To find the y-intercept, I'm going to plug in 0 for x. Okay, so when I plug in 0 for y, I get 3x plus 7 times 0 equals 21. 7 times 0 is just 0, so this is 3x equals 21. To solve for x, I'm going to divide by 3 and get x equals 7. I need to write that as an ordered pair. How would I write that as an ordered pair? 7, 0. For the y-intercept, I'm going to do the same thing, but this time I plug in 0 for x. So 3 times 0 plus 7y equals 21. Three times 0, 0. So this is just 7y equals 21. Divide by 7 and get y equals 3. How do I write that ordered pair? 0, 3. And then I can graph that on a graph now. So 0, 3, I'm sorry, 7, 0, the x-intercept, that's over 7 on your x-axis. Put a dot there. 0, 3 is up 1, 2, 3 on your y-axis. Put a dot there. And then connect your dots with a straight line. And your graph looks something like that. Questions about that? Okay, the next thing we are going to talk about is slope. So just a reminder, this is one of the problems on your comp exam in college algebra. So you have to take that by next Wednesday, your first attempt. Here's one problem you can do. We're going to move on to slope, which is the next section. And that's another problem that's on your comp exam in college algebra. So this is section 3.4, which is slope. Okay, and slope, one way you can tell slope from an equation is if it's in slope-intercept form, it's the number in front of x. We kind of talked about that last time. Another way you can find slope is using the slope formula. The slope formula is m equals y2 minus y1 over x2 minus x1. Okay, and just a reminder, all those x1s and y1s and x2s and y2s, they come from ordered pairs. The first ordered pair is x1, y1. The second ordered pair is x2, y2. Okay, so let's do some problems. Let's start off with the problem. We're finding slope of the line that contains 0, -3, and 2, -5. Okay, so if it's helpful sometimes, one of the biggest mistakes here is plugging the numbers into the wrong spot. So it's helpful if you label your number, or I'm sorry, yeah, label your numbers. I'm gonna label them x1, y1, x2, y2. So then when I plug them in the formula, I get m equals y2, which is -5, minus y1, which is -3, over x2, which is 2, minus x1, which is 0. On top here, -5 minus -3. Some people have a hard time with that. If you need to, you can put it on your calculator. If you're going to put it on your calculator, don't put the whole thing in. Just put like the top end to get the number. It's like -5 minus -3. Is it -5? Yeah. And you get -2 as your answer. Or if you wanted to do it by hand, minus a negative is the same thing as plus a positive. So -5 plus 3 is -2. 2 minus 0 is 2. This you always have to simplify if you can. Can I simplify negative 2 divided by 2? Yeah, what is it? Negative 1. And that's your answer. Let's do another one. Ooh, excuse me. If I had 4, 0, and negative 2, negative 3. Try that one on your own. Okay, so when you plug it in, you should get negative 3 minus 0 over negative 2 minus 4. Negative 3 minus 0 is negative 3. Negative 2 minus 4 is negative 6. And negative 3 over negative 6, what does that simplify to? 1/2. Okay, a negative divided by negative is a positive. 3 and 6 both divide by 3. And when I do that, 3 divided by 3 is 1. 6 divided by 3 is 2. So my answer is 1/2. Question about that? Okay, so there are 2 situations when slope is weird. Okay, that is with vertical lines and horizontal lines. So I want to do one of each of those. That's probably not going to show up on your comp exam, but just in case it does, I want you to be prepared for it. So if I had the ordered pair 3, negative 2, and the ordered pair negative 1, negative 2. We're going to find the slope of that one. So take like a minute and go ahead and practice that. Okay, so when you did this, you got negative 2 minus negative 2, which would be like negative 2 plus 2, which is 0. And negative 1 minus 3 is negative 4. And 0 divided by negative 4, if you needed to do it on your calculator, is 0. The idea of division is like splitting something into parts. So it's like if I have 0 pieces of gum and I'm splitting it among 4 people, how many pieces of gum does everybody get? 0. It's dumb to do it that way, but you can do it, right? Everybody gets 0 pieces. Okay, so the slope here is 0. What kind of lines have 0 slope? Straight across, right? So those would be horizontal lines. So horizontal lines have 0 slope. So those are, this specific line would look like over 3 down 2, negative 1 down 2. So it would look something like this. Okay, so horizontal lines have 0 slope. let's do the other one. Let's do a vertical line now. So if I had the ordered pairs, 2, 5, and 2, -2. Oh, sorry. Let's find the slope of those 2 points. When you get this one, you should have got -7/0. When you divide that one, -7 divided by 0, you should get an error on your calculator, okay? That's because you can't divide by 0. Dividing by 0 is undefined. The idea for that one is if I have 7 pieces of gum and I'm dividing it among 0 people, how many pieces of gum does each person get? Well, you can't give gum to nobody, so like it doesn't make sense to do that problem. Okay, so undefined slope, those are vertical lines. And this specific problem would look something like this, be a vertical line like that. Questions about that? Okay, so those are problems on your comp exam. That's 2 of the problems on your comp exam. So when you take your comp exam on Wednesday, your goal is to make at least a 20 because you can do 2 problems on it, okay? Hopefully you'll do better than that, but if you don't do better than that, like don't be discouraged by that because we still have a whole month to learn everything for your next comp exam after that, okay? So we are going to go ahead and start our first lesson. All of this stuff has been reviewed at this point, just things that you needed to know to be able to kind of get started in college algebra. Okay, so we are going to start on section 5.5, which is factoring, which that is also a part of your comp exam, but it's also just a big part of college algebra. So factoring by GCF and grouping. So we're going to learn, we're not going to get very far in it today, but we're going to start it today and we're going to finish it up on Monday. The thing about factoring, to be successful in this course and to be successful in college algebra, you have to be able to factor. There's not a way around it. Especially if you're a STEM major, you may be going past college algebra. You may be taking pre-cal or other math classes and you have to be able to factor. So we are going to take our time going through it. We're going to go slow today. We're going to go slow on Monday, all of next week, just to make sure you know how to do all of it. You got to do your part of it though. You have to make sure you're understanding it. If you don't understand, you have to stop me and ask questions, or you got to go back and watch this video after I post it to make sure you know how to do it, okay? Also, if you need extra help, you can always go to YouTube and look up factoring. The way that I'm teaching is not the only way to do it. You're more than welcome to do it a different way if you want to. Just you have to know how to factor. Okay, so we're going to start off just talking about the GCF right now. We're not actually going to factor. Okay, so GCF is the greatest common factor. Okay, the non-mathy way to say the greatest common factor is the biggest number that something divides by. Okay, so it's the biggest number that something divides by. And this is something you have been doing a whole lot, your whole life in math. Not a whole life, but a whole bunch at this point. Okay, so we are going to start off by finding, so we're going to find the greatest common factor, give you a second to catch up on your writing. Okay, so find the greatest common factor of 6 and 8. What's the greatest common factor of 6 and 8? So that's what's the biggest number that divides into 6 and divides into 8? Would be 2. Okay, the other one's the least common multiple, and that one's for something different. Okay, let's do another one. Let's find the greatest common factor of, I don't know, of 15 and 20. Yeah, the biggest number that divides into 15 and divides into 20 is 5. What about 4 and 12? 4. 2 is a common factor. It's not the biggest one. Okay, the biggest one is 4. 4 divides into 4. 4 divides into 12. 12 divided by 4 is 3, but the factor is what divides into it. Okay, so 4 would be your answer here. What about of 4 and 7? 1. 1 is the biggest number that divides into both of those. Okay, you got the idea of the numbers? Okay, let's put some letters in there. What about if it was 6x and 8x? Okay, so you can kind of think about the numbers and letters separate. 6 and 8, the GCF is 2. This has 1x, this has 1x. What do they have in common? 1x. So it'd be 2x is your GCF. Okay, let me do another one. What about if it was 6x and 8x cubed? It's still 2x here, and the reason why 6 and 8, obviously the GCF of that is 2. If this has 1x, I could write that like 6 times x. X cubed is like 3 x's multiplied together, right? How many do they have in common? Still 1x. So that's why it's only 2x. Another way to think about it is like you take the smallest exponent. This has a 1 here. So I'm going to use x1 there. Okay, what about if it was 6x squared, 8x, and 12x cubed? So 3 things this time. So you start off looking at your numbers. 6, 8, and 12. What's the GCF of 6, 8, and 12? 2. The first one has 2 x's. The second one has 1x. The third one has 3 x's. What's the most they have in common? 1x. So 2x again. Does that make sense? Okay. What about if we had 15ab, 5a squared b squared, and 25a? Yeah, so you're looking at the numbers, 15, 5, and 25. The GCF is 5. This one has 1a, this one has 2a's, this one has 1a's. What's the most you can take out? 1, or what they have in common is 1. This has 1b, this has 2b's, this has no b's. How many b's do they have in common? None, because this one doesn't have it all, right? So my answer is 5a. Questions about that? What about if it was 6x cubed, 3x squared, and 7x? 1x, right? Because this one has 3 x's, this one has 2 x's, this has 1x, so then common they have 1x. 6, 3, and 7 do not have a GCF. So you could write 1x, or you could just write x. Either one, doesn't matter, same thing. Questions about that? Okay, you ready to move on? Okay, so we're actually going to factor out the greatest common factor. Okay, so factoring out the greatest common factor is the opposite of multiplying. So Like here's a multiplication problem. If I had 2x times x plus 5, and I was going to multiply that, how do you multiply that? Yep. Distribute the 2x into it. What's 2x times x? 2x squared. What is 2x times 5? 10x. Okay, so going this direction in the problem, that's multiplying. If I went the opposite way, if I started with this 2x squared plus 10x, that's like the answer. If I started with that and went backwards, that's factoring. Okay, so factoring is like undistributing or unmultiplying something. Okay, so if you notice, look at the bottom here, 2x squared and 10x. What's the greatest common factor of 2x squared and 10x? 2x, right? Because this one has 2x's, that only has 1x, so they have 1 in common. Look, that's what you're multiplying in is the greatest common factor. So the way we unmultiply it, or the way we factor it out is we find the greatest common factor, and it's like we're pulling it out of the problem. Okay, so our first problem, let's do that problem. Let's do 2x squared plus 10x, and let's factor it. So the first thing you do is find the greatest common factor. What is the greatest common factor of 2x squared and 10x? 2x. So I'm going to write that out front, and then I'm going to open parentheses. What you put inside the parentheses, you're going to divide this out or like unmultiply it if you need to think about it that way. So some people think about it as 2x times what equals 2x squared. You can do it that way. You can divide it. Okay, so you think 2x squared divided by 2x, that's what I do. What's 2 divided by 2? 1. X squared divided by x, or it's like if I have 2 x's and I pull one out, what's left over? 1x. You don't have to put the 1 if you don't want to. It's up to you. Plus, what's 10x divided by 2x? Yeah, 10 divided by 2 is 5. If I have an x and I pull it out, or x divided by x is 1, like it's gone. So it's just 5. And that's my answer. And notice that's what I started with up here. Okay, let's do a few more of those. What if I had the problem 10x to the third power plus 6x? What's the greatest common factor here? 2x. So I'm going to write that out front in parentheses. What's 10x cubed divided by 2x? 10 divided by 2 is 5. If I have 3 x's and I take 1 out, I have 2 x's left over, so 5x squared. Plus, what's 6x divided by 2x? Just 3, because I pulled the x out. I had 1 x and I took it out. So this is your answer. Questions about that? Okay, what about if I had 8x squared plus 4? Yep, the greatest common factor here is 4. When I divide 4 out of the first thing, 8x squared divided by 4? 2x squared. Plus, what's 4 divided by 4? 1. You have to put that 1 there. And that's your answer. Let's do one more. If I had 6x squared minus 3x to the third plus 12x to the fourth. First thing you have to do is find the GCF of 6, 3, 12. What's the GCF going to be?
3x squared.
3. And then this has 2 x's, that has 3 x's, that has 4. The most they have in common is 2. So 3x squared is your GCF. That's what we're going to pull out, or what we're going to divide by. What's 6x squared divided by 3x squared? 2. What's negative 3x cubed divided by 3x squared? Just an x, and then you put a minus sign. You could put minus 1x. You could just put minus x. It's up to you, whatever you want to do. Again, 3 divided by 3 is 1. I had 3 x's. I took 2 out, so I have 1x left over. Okay. And then 12x to the 4th divided by 3x squared? 4x squared. And that is your answer. Okay, we are going to stop there. You now, of all your stuff on D2L, let me pull it up real fast, all your homework on D2L, you can do almost everything that's been assigned at this point. So, here we go. So, your assignments are right here. Continue. Oh, I don't. How does that open? Oh, it's because I'm sorry. I'm in like the teacher version of it. It looks different for you. Let me switch so that it looks the same. Let me go back to here. Stop. Go away. Okay, so let me go here real fast. So Math Excel, homework. There you go. That's what it should look like. You can do all of these. We haven't finished 5.5 yet. So you can start it probably, but we haven't finished it yet. But everything else you can do. If you notice, the first 4 are due on Monday night at midnight, and then the next 2 are due on Wednesday night at midnight. So just kind of think about your schedule. For some people, they don't work on the weekends, and so weekends are a good time to catch up on your homework. For some people, you only work on the weekends, so maybe weekend's not the time to do it. You need to do it during the week. Just make sure you're not waiting until Sunday night at 11:30 to start these 4 assignments. You could probably get it done and then, but if the internet's down or whatever, just make sure you're staying on top of it because you have 7 days to do it. So that's all due on Monday. I meant to say Monday, not Sunday. That's all due Monday night at midnight, and then these are due Wednesday night. That's due next Friday. So make sure you're working on your homework and have a good weekend. Come talk to me if you have any questions.